There's something almost magical about looking up at the night sky. The same stars that have guided explorers, inspired poets, and sparked myths for thousands of years still shine down on us today. But what if those glittering lights held secrets far beyond the stories we've told about them? What if the constellations we trace with our fingers, the legends we whisper around campfires, are just the beginning of a much deeper truth? Tonight, we're setting off on a journey where ancient myths collide with the cutting edge of science, where the gods and monsters of old meet the mind-bending realities of modern astronomy. Think about the last time you gazed up at the stars. Maybe you spotted Orion, the mighty hunter, or followed the curve of the Big Dipper. These patterns have been passed down through generations, woven into cultures across the globe. But behind every myth lies a hidden layer of science, a black hole lurking where ancient civilizations saw a cosmic serpent, or a nebula glowing where storytellers imagined the birth of a god. The night sky has always been humanity's first storybook, and now, with the tools of modern astronomy, we're finally learning to read between the lines. This isn't just a tale of stars and galaxies, it's a story about us, about how we've tried to make sense of the universe, first with stories, then with equations. From the Babylonians mapping the heavens to the Hubble telescope capturing light from the edge of time, our understanding has evolved, but the wonder remains the same. So join me as we unravel the threads of myth and science, discovering how the night sky has shaped our past and how it might just hold the key to our future. The cosmos is waiting, and its secrets are more extraordinary than anything our ancestors could have dreamed. Ancient cultures didn't just see random dots of light when they looked upward, they saw a canvas teeming with meaning. Picture a Babylonian priest tracing the path of Venus and calling it the goddess Ishtar, or an Aboriginal elder pointing to the emu in the dark, not a constellation of stars, but the silhouette of an emu stretched across the Milky Way. These stories weren't mere fantasies, they were the first scientific theories, humanity's way of making sense of eclipses, comets, and the shifting seasons. The Greeks turned star clusters into the tragic figure of Orion, forever chasing the Pleiades across the sky, while the Maya saw the gaping mouth of the cosmic crocodile in the dark rift of the Milky Way. Every civilization, from the Norse to the Navajo, projected their fears, hopes, and understanding of nature onto the stars. What's fascinating is how often these myths aligned with celestial events they couldn't fully explain. The Chinese legend of the dragon eating the sun, that was their way of describing a solar eclipse. The Norse myth of the wolves chasing the sun and moon. A poetic interpretation of celestial motion. Even the Zodiac, with its 12 signs, began as a practical tool. Babylonian farmers used it to track planting seasons long before it became tied to horoscopes. These stories were functional, a blend of astronomy and oral tradition passed down to navigate, predict, and survive. Yet the real magic lies in how these myths transcended borders. The Pleiades star cluster, for instance, appears in Greek mythology as seven sisters, in Japanese folklore as Subaru, and in Cherokee tradition as a group of children who escaped to the sky. Different cultures, same stars, each interpreting them through their own lens. Today, when astronomers point telescopes at these celestial objects, they uncover nebulae and young stars where ancients saw divine figures. The science doesn't erase the myths, it adds layers to them, revealing how human imagination and cosmic reality have always been intertwined. So the next time you spot a familiar constellation, remember, you're not just seeing stars. You're glimpsing the collective dreams of countless generations, a tapestry of stories woven into the fabric of the night sky. And as we'll soon discover, some of those ancient observations hold surprising truths that modern science is only beginning to unravel. For thousands of years, the heavens belonged to the gods until a simple tool changed everything. When Galileo first pointed his telescope at Jupiter in 1610, he didn't just spot 4 tiny dots orbiting the planet, he shattered an entire worldview. Those dots were moons, undeniable proof that not everything revolved around Earth, as the Church and ancient scholars had claimed. Imagine the shockwave that sent through society suddenly. The universe wasn't a neat, Earth-centered stage for human drama, but something far vaster and more humbling. This wasn't just a discovery, it was a revolution, one that would pry the stars from the hands of mythmakers and hand them to mathematicians. Yet the shift wasn't instant. For centuries, comets had been seen as Omens, celestial messengers predicting the fall of kings or the outbreak of plague. Then came Isaac Newton, who traced their glowing paths not to divine will, but to gravity's unbreakable laws. Halley used those same calculations to predict a comet's return, stripping away its supernatural reputation forever. Even the Milky Way, once imagined as a river of souls or the spilled milk of a goddess, was revealed by telescopes to be a sea of stars so numerous they blurred together. Each revelation chipped away at the old stories, replacing them with equations and evidence. But here's the twist: science didn't erase the magic, it relocated it. The same people who marveled at Galileo's discoveries still felt awe under a starry sky. Kepler, while mapping planetary motion, wrote of the cosmos as a hymn sung by God. Modern astronauts armed with quantum physics still describe seeing Earth from space as a spiritual experience. The tension between wonder and understanding isn't a battle, it's a dance. We no longer blame eclipses on sky serpents, yet the hairs on our necks rise just the same when the moon swallows the sun. What's truly remarkable is how much ancient intuition got right, despite lacking our tools. The Maya calculated Venus's cycle with astonishing precision, while Polynesian navigators crossed oceans using stars their myths described as ancestors guiding them home. Even the Greek idea of atoms, tiny, indivisible bits of matter, wasn't far off from what quantum physics would confirm millennia later. The old myths weren't just wrong, they were often the first drafts of scientific truth, shaped by observation and necessity. Today, we stand at a peculiar crossroads. We can measure the spin of distant pulsars and peer back to the universe's infancy. Yet we still name Mars rovers after mythological concepts like perseverance and curiosity. Maybe that's the real lesson. Science doesn't kill mystery, it deepens it. Every answered question unveils new ones, keeping the night sky as tantalizing as it was to our ancestors. The stories have changed, but the staring upward, the wondering, that part remains. Take Orion, for example, that unmistakable pattern of stars with his belt and raised club. To the ancient Greeks, he was a giant hunter placed among the stars by Zeus, forever pursuing the Pleiades across the celestial sphere. But point a telescope at Orion's sword, and you'll find something even more extraordinary: the Orion Nebula, a vast stellar nursery where new stars are born. The same patch of sky that inspired tales of divine punishment now reveals the physics of star formation, with swirling gas and infant suns. It's as if the myth was a placeholder, a story waiting for science to fill in the details. Or consider Ursa Major, the Great Bear. Nearly every Northern Hemisphere culture saw a bear in those 7 bright stars, from Native American legends to Greek myths about a transformed nymph. Yet today, astronomers know those stars aren't even gravitationally bound, they're just a chance alignment from Earth's perspective, drifting apart over millennia. The Big Dipper's handle, that's an asterism within the constellation, a useful navigation tool for travelers and spacecraft alike. What once guided lost wanderers now helps calibrate deep space probes, proving that even our oldest sky maps still have practical value. Then there's the Pleiades, those tight-knit stars often called the Seven Sisters. Cultures from Japan to Australia wove stories about them, usually involving lost sisters or protective ancestors. Modern astronomy reveals they're a young star cluster, barely 100 million years old cosmic teenagers compared to our Sun. Their blue glow isn't magic but starlight reflecting off interstellar dust, a phenomenon we can now measure down to the nanometer. What's remarkable is how these dual interpretations coexist. Satellite telescopes plot Orion's stars by their exact coordinates, while poets still write about his mythical hunt. The Big Dipper's stars help astronomers measure galactic distances, yet children still connect its dots to trace a bear. Perhaps that's the real magic of constellations, their bridges between wonder and knowledge, reminding us that understanding the universe doesn't have to mean stripping away its mystery. After all, isn't there something profound about knowing that the same stars that sparked our ancestors' imaginations are now teaching us how galaxies evolve? The myths weren't wrong, they were just the first chapter in a much longer story. Eclipses have always had a way of stopping us in our tracks, whether you're standing in the shadow of the moon today or trembling beneath a suddenly darkened sky 3,000 years ago. To the ancient Chinese, a solar eclipse meant a celestial dragon was devouring the sun, and they'd bang drums and pots to scare it away. The Vikings told of wolves chasing the sun and moon, finally catching them in a momentary celestial struggle. Even the Inca believed eclipses were a sign of the sun god's displeasure, a divine warning that demanded sacrifices to restore balance. These weren't just stories. They were attempts to explain the unexplainable, to impose order on a universe that seemed to rebel against predictability. Fast forward to the modern era, and we know exactly why eclipses happen: the moon's orbit aligning perfectly between Earth and the sun, casting its shadow like a cosmic bullseye. We can predict them centuries in advance, down to the millisecond, tracing their paths across continents with pinpoint accuracy. The same event that once sparked panic now draws crowds of eclipse chasers armed with telescopes and solar filters, eager to witness the precise alignment Newton's laws foretold. Science has turned what was once a terrifying omen into a shared moment of wonder, a testament to human curiosity. Yet here's the beautiful paradox: even with all our knowledge, eclipses haven't lost their power. When day suddenly turns to night and the temperature drops, when birds stop singing and stars appear in midday, logic takes a backseat to sheer awe. Astronomers and school children alike gasp as the sun's corona flares into view, a halo of plasma visible only when the moon blocks its blinding face. That visceral reaction bridges the gap between ancient and modern, proof that understanding the mechanics doesn't diminish the magic. What's fascinating is how eclipses have quietly shaped history. In 613 BCE, a solar eclipse over the ancient kingdom of Lydia allegedly halted a raging battle, as both armies saw the darkened sky as a sign to lay down their weapons. Centuries later, Einstein used a total eclipse to prove his theory of relativity, as starlight bending around the sun confirmed space itself could warp. From superstition to groundbreaking science, eclipses have been silent witnesses to humanity's evolving relationship with the cosmos. Today, we've come full circle. Indigenous communities still share oral traditions about eclipses, while NASA live streams them to millions. The difference is we no longer fear them, we anticipate them. But in that shared moment of darkness, when the moon's shadow races across the Earth at over 1,000 miles per hour, we're reminded that some experiences transcend explanation. The sky doesn't care if we call it mythology or orbital mechanics. It leaves us humbled either way, and perhaps that's the real lesson, that wonder and understanding aren't opposites, but two sides of the same cosmic coin. Comets have always had a way of shaking humanity to its core, those sudden streaks of light with glowing tails, appearing without warning against the backdrop of familiar stars. To ancient civilizations, they were celestial firebrands, ominous signs scribbled across the sky by the gods themselves. When Halley's Comet blazed overhead in 1066, it was seen as a portent of doom, heralding the Norman conquest of England just weeks later. The Aztecs interpreted comets as the fiery breath of the war god Huitzilopochtli, while European monarchs trembled, convinced these hairy stars foretold their downfall. Even as late as 1910, when Halley's Comet returned, charlatans sold comet pills to panicked crowds, claiming they could ward off the poison supposedly carried in its tail. Fear of the unknown turned these icy visitors into mythic monsters. Yet beneath the superstition lay something remarkable: meticulous observation. Chinese astronomers as early as 240 BCE recorded Comet Halley's movements with astonishing precision, noting its path like cosmic scribes. Kepler, studying the Great Comet of 1617, dared to suggest its tail was not flame but sunlight reflecting off vaporized material, a radical idea at the time. These early stargazers were piecing together clues without the tools to solve the puzzle, their curiosity cutting through the fear. Fast forward to today, and comets have transformed from objects of dread to scientific treasure chests. We now know they're ancient relics, icy time capsules left over from the solar system's birth 4.5 billion years ago. When the Rosetta spacecraft landed on Comet 67P in 2014, it didn't find a harbinger of doom. It found organic molecules, the building blocks of life, preserved in pristine ice. Halley's Comet, once a medieval nightmare, now helps us map the solar system's gravity like a celestial measuring tape. Even the tales that terrified our ancestors reveal their secrets: not smoke or poison, but sunlight pushing against dust and ionized gas, a process we've harnessed to design solar sails for future spacecraft. The real twist: some of those old myths weren't entirely wrong. The idea that comets brought change wasn't pure fantasy, just misdirected. We now suspect comet impacts delivered water to young Earth, possibly even the organic ingredients for life. The dinosaurs might argue they were indeed agents of doom, given their extinction event 66 million years ago. And when comet Shoemaker Levy 9 slammed into Jupiter in 1994, astronomers watched in real time as a cosmic bullet left scars larger than Earth on the gas giant, a visceral reminder that the solar system is still a shooting gallery. What's beautiful is how this duality persists. Modern comet hunters still feel a primal thrill spotting a new fuzzy dot in their telescopes, just as their ancestors did. Amateur astronomers camp out under dark skies to photograph their shimmering tails, while researchers analyze comet dust for clues to our origins. The difference is we no longer cower, we chase them. Spacecraft like Stardust and Deep Impact have flown through comet tails, even blasted craters into their surfaces to study what lies beneath. The fear has evaporated, replaced by a hunger to understand. Perhaps that's the greatest lesson comets teach us. Knowledge doesn't strip away wonder, it redirects it. Those icy wanderers once thought to be divine warnings are now time machines, carrying whispers from the solar system's infancy. The next time a comet graces our skies, you'll know the truth. You're not seeing an omen, but a fossil. A snowball stamped with the signature of the cosmos itself, reminding us that even the most terrifying mysteries can become sources of revelation when met with curiosity instead of fear. The moon has always been more than just a rock in the sky. It's been a mirror reflecting humanity's evolving understanding of the cosmos. To the ancient Greeks, it was Selene, a silver goddess riding her chariot across the night, her phases dictating the rhythms of harvest and myth. The Maya charted its cycles with such precision they could predict eclipses centuries in advance, while Pacific Islanders used its light to navigate thousands of miles of open ocean. These weren't just stories, they were survival tools, ways of marking time and space in a world without clocks or maps. The moon was a celestial clock, a divine calendar, and sometimes a capricious deity demanding offerings. Fast forward to July 20, 1969, when Neil Armstrong's boot left the first human imprint in lunar dust. In that moment, the moon transformed from a distant symbol to a tangible place, a world with craters to map, rocks to collect, and gravity 1/6 of Earth. The same orb that once inspired poets became a laboratory, its barren surface holding clues to Earth's violent infancy. Those Apollo-era moon rocks revealed something astonishing. Our planet and its satellite share a common origin, likely born from a cataclysmic collision between early Earth and a Mars-sized object. The myth spoke of the moon as a companion. Science confirmed it was literally a piece of home, torn away and frozen in time. Yet the moon's scientific value goes far beyond geology. Its far side, forever hidden from Earth, is a radio-quiet haven where telescopes could peer into the universe's darkest corners without interference. Its ice-filled polar craters might one day supply water for astronauts, splitting into hydrogen for fuel and oxygen for breathing, and its low gravity makes it the perfect launchpad for deeper space missions, a cosmic stepping stone to Mars and beyond. NASA's Artemis program isn't just about returning humans to the moon. It's about building a sustainable future there, turning what was once the domain of gods into a hub for interplanetary exploration. What's mesmerizing is how the old and new narratives intertwine. The same craters once seen as the man in the moon by folklore are now known as impact basins from ancient asteroid strikes. The moon illusion, where it appears larger near the horizon, puzzled cultures for millennia today. We understand it's a trick of perception, not magic. Even lunar eclipses, once feared as omens, are now celebrated events, their reddish hue explained by sunlight filtering through Earth's atmosphere. Science hasn't erased the moon's mystique, it's given us new language to describe its wonders. Perhaps the most profound shift is in our relationship to the moon itself. We no longer pray to it, but we depend on it more than ever. Its gravity stabilizes Earth's tilt, preventing chaotic climate swings, while its tides shaped the evolution of coastal life. The Artemis generation might soon walk its surface not as conquerors, but as caretakers, tapping its resources while preserving its stark beauty. From goddess to outpost, the moon's story is ultimately ours, a testament to how far we've come, and a reminder that the cosmos still has infinite lessons to teach. The next time you gaze up at that familiar glow, remember, you're looking at humanity's past, present, and future, all wrapped in one silent, silver world. Mars has always stood out in the night sky, a fiery dot that refused to twinkle like the other stars, its rust-colored glow stirring both fear and fascination. Ancient civilizations didn't just see a planet, they saw a god. To the Babylonians, it was Nergal, the harbinger of war and pestilence. The Greeks called it Ares, a tempestuous deity whose rage mirrored the planet's ruddy hue. When the Romans renamed it Mars, they cemented its reputation as a celestial warrior, a symbol of violence and virility. Even its two irregular moons, Phobos and Deimos, were named for the sons of Ares, fear and terror. For millennia, Mars wasn't just a world, it was a warning, a cosmic reflection of humanity's darkest impulses. Then came the telescopes. In 1877, Italian astronomer Giovanni Schiaparelli peered through his lens and sketched what he called canali, Italian for channels, but mistranslated as canals. The idea of artificial waterways on Mars exploded in the public imagination, fueling fantasies of a dying civilization desperate to save itself. Percival Lowell spent years mapping these illusory canals, convinced they were proof of intelligent Martians battling extinction. Science fiction ran wild, from H.G. Wells' warlike tripods in the War of the Worlds to Ray Bradbury's poetic Martian chronicles. Mars was no longer just a god, it was a mirror reflecting our hopes and fears about life beyond Earth. The space age shattered those myths but replaced them with something even more compelling. When Mariner 4 flew past Mars in 1965, it didn't find canals or cities, just a cratered wasteland. Yet beneath that barren surface, clues began to emerge. Viking landers in the 1970s scooped up soil, hunting for microbial life. Though inconclusive, the experiment sparked a question we're still chasing. If life could arise on Earth, why not Mars? Today's rovers' Curiosity, Perseverance, and their robotic kin are geological detectives, analyzing ancient riverbeds and lakebeds for fossils or chemical traces of long-gone organisms. Every layer of sedimentary rock is a page in Mars' biography, hinting at a time billions of years ago when water flowed and the planet might have been habitable. Now, Mars is undergoing its most radical transformation yet, from a place we study to a place we might inhabit. Visionaries like Elon Musk talk of terraforming, of thickening its atmosphere and melting polar ice to create a second home for humanity. Scientists debate the ethics of contaminating Mars with Earth microbes or the practicality of building domed cities under its pinkish sky. The red planet is no longer a distant symbol. It's a challenge, a backup plan, a laboratory for testing how life might spread across the cosmos. What's striking is how Mars' story parallels our own evolution, from superstition to science, from mythology to mission control. The same planet once feared as a war god now draws engineers designing hydroponic farms for its barren soil. The canals Lowell imagined are dry river valleys, but they still whisper of a time when Mars was alive. Perhaps that's the real lesson. Mars was never just a planet. It's a canvas constantly repainted by our imagination and ingenuity. And as we stand on the brink of becoming an interplanetary species, one thing is certain: the next chapter of Mars' story will be written not just by astronomers but by explorers. The god of war may yet become the cradle of a new branch of humanity. Black holes have always lurked at the edges of human imagination, long before we had the mathematics to prove they existed. Ancient myths spoke of bottomless pits, of dragons that swallowed the sun, of cosmic beasts whose hunger could never be satisfied. The Norse feared Fenrir, a wolf so vast his jaws stretched from earth to sky, while Hindu texts described the all-consuming goddess Kali. These weren't just stories, they were attempts to give form to the formless, to name the unspeakable void. Fast forward to 1919, when Einstein's equations first hinted at regions of space where gravity was so strong, not even light could escape. Scientists dismissed the idea as absurd until nature proved them wrong. The first photograph of a black hole, captured in 2019, revealed something astonishing: a fiery ring of light circling perfect darkness, like a monstrous eye staring back at us from 55 million light-years away. That image of Messier 87's supermassive black hole didn't just confirm a theory, it made the invisible visible, turning an abstract equation into a cosmic landmark. The resemblance to ancient myths was uncanny. The same cultures that imagined gaping celestial mouths would have recognized that fiery ring instantly, not as science but as prophecy. What makes black holes so unsettling is how they defy every instinct. Time slows to a crawl near their event horizons, stretching seconds into eternities. Matter gets shredded into spaghetti-thin strands in a process literally called spaghettification. Even their size boggles the mind. The smallest might be as tiny as an atom, while supermassive ones like Sagittarius, a star at our galaxy's heart, weigh as much as 4 million suns. They're not just objects, they're paradoxes, places where the laws of physics as we know them break down completely. Yet for all their destructive power, black holes might also be cosmic architects. Their collisions send ripples through space-time itself, gravitational waves we can now detect like echoes from a drumbeat. They may even seed new stars, their violent energy compressing gas clouds into stellar nurseries. Some theories suggest they're gateways to other universes or time machines warping the fabric of existence. The same forces that annihilate might also create, blurring the line between monster and maker. This duality is what keeps black holes fascinating. They're the ultimate unknown, the place where science and myth converge. When you look at that first photograph, that golden ring of light framing infinite dark, you're seeing something our ancestors sensed but couldn't name. A reminder that the universe has always been wilder than our stories, and that sometimes the truth is stranger than anything we dared to dream. Imagine staring up at the night sky in 1054 AD and suddenly seeing a new star appear brighter than Venus, visible even in daylight for weeks. That's exactly what Chinese astronomers recorded, calling it a guest star, a celestial visitor that didn't belong to them. It was an omen, a message from the heavens about the emperor's reign. Halfway across the world, the ancestral Pueblones in Choco Canyon may have painted that same cosmic event on their cliff walls, a handprint beside a star, as if marking the moment the sky itself changed. These weren't just random observations, they were attempts to make sense of the unfathomable, to find meaning in a universe that had just ripped open its veil. What those ancient stargazers witnessed was a supernova, the catastrophic death of a star, exploding with the energy of a billion suns. Today, we know these explosions aren't omens but cosmic forges, the fiery furnaces where elements like gold, silver, and uranium are born. Every ounce of gold in your jewelry, every iron atom in your blood, was once hurled into space by a dying star's final act. The very materials that make up our planet and us were forged in these violent stellar deaths. It's a staggering thought. The calcium in your bones was once stardust, scattered across the galaxy by an explosion that lit up the sky centuries before telescopes existed. The contrast between ancient and modern interpretations couldn't be sharper, yet both contain a kernel of truth. Supernovas are messengers, just not in the way our ancestors imagined. Their light carries data about the universe's expansion, helping astronomers measure cosmic distances. They're remnants like the Crab Nebula, the swirling aftermath of that guest star from 1054, act as natural particle accelerators, teaching us about physics under conditions no lab could replicate. Even their destruction is creative. Shock waves from these explosions trigger the collapse of nearby gas clouds, sparking the birth of new stars. The cycle is poetic. A star dies so others may live, scattering the ingredients for planets and life across the cosmos. What's mesmerizing is how often ancient intuition aligned with scientific reality. The Chinese weren't wrong to see supernovas as transformative events. They just didn't know the transformation was literal. The Maori legend of Takioyua, the winter star, speaks of a celestial being whose death brought fire to Earth, eerily close to the idea of stellar material seeding planets. Even the biblical Star of Bethlehem might have been a supernova, a divine sign reinterpreted through modern astronomy. These stories weren't mere myths. they were humanity's first attempts to explain the inexplicable, to find narrative in chaos. Now we hunt supernovas not with omens but with algorithms, telescopes scanning the skies for these cosmic fireworks. When one erupts, astronomers rush to capture its light, decoding the elements it spews into space. Citizen scientists comb through data, sometimes spotting these explosions before the professionals. The fear has turned to fascination, the mysticism to methodology. Yet when you look at Hubble's images of supernova remnants, those delicate, glowing tendrils of gas, it's hard not to feel the same awe that gripped ancient sky watchers. The stories have changed, but the wonder remains. After all, isn't there something profound about knowing that the same force that once terrified our ancestors is the reason we exist at all? The Zodiac is one of humanity's oldest celestial maps, a belt of 12 constellations that trace the sun's apparent path across the sky, each assigned to a slice of the year. The Babylonians first carved up this cosmic highway around 3,000 years ago, using it to track planting seasons and royal omens. Their system was practical, grounded in the rhythm of the stars, but over centuries it morphed into something far more personal: astrology, the belief that these distant star patterns shape our personalities and destinies. Today, millions check their horoscopes daily, convinced that the sky holds coded messages just for them. Yet modern astronomy tells a very different story, one where the zodiac is less a mystical guide and more a cosmic clock that's slowly ticking out of sync. Here's the twist. Due to a wobble in Earth's axis called precession, the constellations have drifted over millennia. When the Babylonians named Aries the ram as the first sign, the sun actually sat in that constellation during spring. But 2,500 years later, the sun now spends spring in Pisces and will soon slide into Aquarius despite what horoscopes claim. This shift means your star sign likely doesn't match the constellation behind the sun on your birthday. Astrology brushes this aside, clinging to the Babylonian framework, while astronomy sees it as proof that the stars are indifferent to human affairs. The Zodiac, once a farmer's almanac, has become a battleground between belief and empirical truth. What's fascinating is how both interpretations reveal something profound about us. Astrology thrives because it offers narrative, a way to tether our chaotic lives to something grand and ordered. The idea that Capricorns are ambitious or Leos charismatic gives comfort, a sense that the universe has a plan. Astronomy, meanwhile, strips away that narrative to expose sheer scale. Those zodiac constellations are light years apart, their shapes arbitrary, their alignment with Earth seasons temporary. The Pleiades, part of Taurus in astrology, are actually a separate star cluster drifting through space, unrelated to the bull's mythical outline. Yet the zodiac's scientific legacy is undeniable. Early astronomers like Ptolemy used it to catalog stars, and navigators relied on its patterns long before GPS. Even NASA Voyager probes carry zodiac references on their golden records, not as astrology, but as a cosmic roadmap for any extraterrestrial finders. The constellations might not dictate fate, but they've guided explorers, inspired artists, and fueled discovery. Whether you see them as celestial storytellers or stellar landmarks, their influence is written across history. Perhaps the real lesson lies in the tension itself. The human brain craves patterns, whether in star arrangements or tea leaves, while the universe operates on laws indifferent to our yearnings. The zodiac endures not because it's true in an astrological sense, but because it bridges two timeless impulses: to seek meaning in the unknown and to map that unknown with relentless curiosity. So the next time you glance at your horoscope, remember, you're part of a tradition stretching back to Babylon, a tradition that once mixed stargazing with survival. The stars haven't changed, but our understanding of them, that's a story still being written. auroras don't just light up the sky, they ignite the imagination. To the Inuit, those shimmering curtains were the spirits of the dead playing ball with a walrus skull, their laughter crackling across the frozen night. Viking sagas whispered of Valkyries riding through the heavens, their armor reflecting the fires of Valhalla. Even the Sami people hung silent in reverence, believing the lights were the energy of unborn souls. These weren't just pretty lights, they were stories written across the cosmos, a celestial language older than writing itself. Now, science pulls back the curtain on the magic, or so we think. Those dancing ribbons are actually solar wind particles, flung from the sun's surface, racing toward Earth at 1,000,000 miles per hour. When they collide with our atmosphere, they energize oxygen and nitrogen atoms, which release photons in bursts of green, red, and violet. It's a cosmic chemistry experiment, predictable as clockwork, mapped by satellites and studied by physicists. Yet here's the paradox: even when you know the equations, standing beneath an aurora still steals your breath. The science explains the how, but it can't quite capture the why of that primal awe. What's fascinating is how often the old myths got eerily close to the truth. The Inuit warned against whistling at the lights, fearing they'd swoop down to carry you away, a poetic parallel to how charged particles follow Earth's magnetic field lines toward the poles. Finnish legend spoke of the firefox whose tail sparks painted the sky, not unlike the way solar flares trigger geomagnetic storms. These cultures, without spectrometers or satellites, sensed the aurora's connection to something vast and unseen. Modern research has only deepened the wonder. We've discovered auroras on other planets. Jupiter's are 1,000 times more powerful than Earth's, fueled by volcanic moons. Satellites have caught Steve, a mysterious purple streak that defies traditional aurora physics, proving there's still much to learn. Even the sounds reported for centuries, crackles and hisses during intense displays, were long dismissed as folklore until recordings confirmed their reality. The sky, it seems, still holds surprises. Perhaps that's the real magic of auroras. They're a bridge between worlds. To ancient peoples, they were proof the universe was alive, watching, reacting. To scientists, they're a diagnostic tool, revealing secrets about Earth's magnetic field and space weather. But for anyone who stood beneath their glow, there's something more, a reminder that some experiences transcend explanation. The equations may describe the dance, but the dance itself, that belongs to the stars. Time has always been more than just numbers on a clock. It's been woven into the very fabric of human existence, shaped by the heavens above and the rhythms of the earth below. Picture a Babylonian priest scanning the night sky, not just for omens, but to mark the precise moment the crescent moon reappeared, signaling the start of a new month. Or imagine an Egyptian scribe noting how the annual flooding of the Nile coincided with Sirius rising just before dawn, a celestial event so reliable it became the cornerstone of their calendar. These weren't mere observations, they were acts of survival, ways to predict planting seasons, religious festivals, and even the reigns of kings. Timekeeping began as a sacred dialogue between humanity and the cosmos, where gods and planets dictated the turning of days. Fast forward to today, and the contrast couldn't be starker. Atomic clocks, like the ones at the heart of GPS satellites, measure time by counting the vibrations of cesium atoms, a process so precise it would take 100 million years to lose a single second. Pulsars, those distant spinning neutron stars, act as cosmic metronomes, their rhythmic flashes so consistent they rival our best terrestrial timepieces. Science has stripped away the mysticism, replacing celestial omens with equations and quantum mechanics. Yet traces of those ancient rhythms still linger in our daily lives. Take the 7-day week, a system inherited from the Babylonians who assigned each day to one of the 7 visible planets, including the Sun and Moon. Sunday for the Sun, Monday for the Moon, and even Saturn's hold on Saturday echoes of a time when time itself was divine. What's fascinating is how these two worlds, myth and precision, coexist. The Gregorian calendar we use today is a patchwork of astronomy, politics, and religion, with its leap years and papal decrees. Even time zones, those neat slices of longitude, are a compromise between solar time and the demands of railroads and telegraphs in the 19th century. The past isn't erased, it's embedded in the machinery of modernity. When you check your smartphone for the time, you're tapping into atomic clocks, but you're also glimpsing the shadow of ancient stargazers who first sought order in the chaos of the heavens. Perhaps the most profound shift isn't just in how we measure time, but in how we perceive it. For our ancestors, time was cyclical, seasons returning, empires rising and falling, the stars wheeling overhead in an endless loop. Now we see time as linear, our arrow hurtling forward, segmented into nanoseconds and productivity quotas. Yet even in this age of atomic precision, we still feel the pull of those older rhythms. The allure of a full moon, the restlessness of equinoxes, the way an hour can stretch or collapse depending on the light. Time may be a number, but our relationship with it, that's still written in the stars. Every culture that's ever looked to the stars has asked the same fundamental question: where did all of this come from? The answers they've woven are as diverse as humanity itself. The Aboriginal people of Australia spoke of the dream time when ancestral spirits shaped the land and sky into being. The Norse described a void called Ginnungagap, where fire and ice collided to birth the first giant. The ancient Egyptians believed the sun god Ra rose from primordial waters, while the Mayans told of a creator who spoke the world into existence from nothingness. These weren't just stories, they were entire cosmologies, frameworks for understanding existence itself. Now fast forward to the 20th century, when a Belgian priest and physicist named Georges Lemaitre proposed something equally extraordinary: that the universe began as a single, infinitely dense point, a primeval atom that exploded outward in a cataclysmic release of energy. What we now call the Big Bang Theory started as a radical idea, dismissed by many as mere speculation dressed in equations. Yet over decades, evidence piled up: the redshift of galaxies racing away from us, the cosmic microwave background radiation, the afterglow of that initial fireball, and the precise ratios of hydrogen to helium left over from the universe's first minutes. Science had its own creation story, one written not in myth but in math. What's mesmerizing is how these vastly different narratives circle the same profound mystery. The Cuba people of Central Africa described creation as a burst of sound, a cosmic Big Bang of their own, while Hindu texts spoke of the universe cycling through endless births and deaths, a startling parallel to modern theories of a multiverse or oscillating cosmos. Even the biblical "let there be light" finds an echo in the Big Bang's sudden eruption of photons. These parallels aren't coincidences. They're proof of humanity's relentless drive to make sense of the void. Yet the differences are just as revealing. Ancient myths often placed humans at the center of creation. Gods shaped the world for us, or we emerged from its very fabric. The scientific story humbles us. We're latecomers inhabiting a speck of dust orbiting an average star in one of billions of galaxies. The Big Bang didn't happen for us, we happened because of it. And while myths often end with a finished universe, science reveals one still unfolding: galaxies spinning away from each other in a dance that began 13.8 billion years ago. Perhaps the most beautiful twist is how modern cosmology has borrowed from the oldest questions. The concept of quantum fluctuations, tiny ripples in the fabric of spacetime that seeded galaxies, mirrors the Maori idea of the universe stirring from a state of potential. Inflation theory, with its exponential expansion in the first fraction of a second, feels as wondrous as any deity stretching the heavens. Even the unanswered questions, what came before the Big Bang? What lies beyond the observable universe, sound like the riddles posed by ancient sages. This isn't a contest between myth and science, it's a continuum. The same awe that led a shaman to trace constellations now drives physicists to hunt for dark matter. The storytellers who imagined world serpents circling the Earth wouldn't be surprised to learn we live in a curved, expanding spacetime. Both traditions, in their own ways, remind us that the universe is stranger than we can imagine, and that the act of wondering, of reaching for answers, is what makes us human. Whether you find poetry in equations or in epic tales, the night sky still whispers the same invitation: look and dream. Dark matter is the cosmic shadow we can't see but can't ignore, a mystery as tantalizing today as the concept of the ether was to 19th century scientists. Back then, physicists believed space wasn't empty but filled with an invisible substance called luminiferous ether, a medium through which light waves supposedly traveled. It was an elegant idea, a way to explain how light could propagate through the void. But when experiments like Michelson and Morley's failed to detect it, the ether vanished from textbooks, becoming a cautionary tale about clinging too tightly to untested assumptions. Dark matter, though, is different. We can't see it, can't touch it, yet its gravitational fingerprints are everywhere, bending starlight, spinning galaxies faster than they should, and sculpting the universe's very structure. The parallels between ether and dark matter are striking, but so are the differences. The ether was a placeholder, a solution in search of a problem. Dark matter, on the other hand, is a problem demanding a solution. Take galaxy rotation. Stars on the outer edges of spiral galaxies whip around at speeds that defy Newton's laws unless there's 10 times more mass than what's visible, hidden in some unknown form. When astronomers like Vera Rubin first documented this in the 1970s, the data was undeniable. Even Einstein's theory of general relativity points to dark matter's existence, with its gravitational lensing effects revealing massive, invisible halos around galaxy clusters. Unlike the ether, dark matter isn't a failed hypothesis. It's an unanswered question written in the cosmos itself. What's fascinating is how dark matter mirrors humanity's oldest storytelling instincts. Just as ancient cultures invented gods to explain thunderstorms or eclipses, modern physicists conjure terms like weakly interacting massive particles or actions to label the invisible. The impulse is the same: to name the unnamed, to map the void. Even the methods echo the past. Indigenous navigators once read ocean currents they couldn't see by watching the stars. Today, astronomers map dark matter's distribution by tracing how it warps the light of distant galaxies. Both are acts of deduction, of seeing the unseen, yet the stakes couldn't be higher. Dark matter isn't just academic, it's the scaffolding of the universe. Without it, galaxies would fly apart and cosmic webs wouldn't have formed. Some theories suggest it might even hold clues to extra dimensions or parallel universes. Experiments deep underground, in particle colliders, and even in space hunt for its elusive particles, each failure narrowing the possibilities. The irony. We're like the ancient Greeks who knew the stars moved but didn't yet grasp gravity. We see the effects but not the cause. Perhaps that's the real lesson of dark matter: humility. For all our telescopes and supercomputers, 85% of the universe's mass remains a cipher. It's a reminder that science, like myth, is a work in progress, a story we're still writing, one observation at a time. And just as the ether's demise led to relativity, solving dark matter could rewrite physics itself. Until then, it stands as both a monument to our curiosity and a beacon urging us to look deeper. After all, the universe rarely reveals its secrets easily, but that's what makes the search worth pursuing. Exoplanets force us to confront a humbling truth. Earth might not be the center of the universe, but it's also not the only stage where life could unfold. Centuries before telescopes confirmed their existence, philosophers like Giordano Bruno dared to imagine other worlds orbiting distant suns. In 1600, that radical idea cost him his life, condemned as heresy by a church unwilling to relinquish humanity's cosmic exclusivity. Fast forward to 1992, when astronomers Alexander Wolskson and Dale Frail made an astonishing discovery: 2 planets orbiting a pulsar, a dead star's corpse. Not a theoretical possibility, but concrete evidence that planets could exist beyond our solar system. The floodgates opened today. We've confirmed over 5,000 exoplanets, gas giants with diamond rain, molten lava worlds, and rocky planets nestled in their star's habitable zone, where liquid water might pool. What's fascinating is how these discoveries echo ancient debates. The Greek philosopher Democritus speculated about countless worlds in the 5th century BCE, while Aristotle insisted Earth was unique. Medieval scholars like Ibn Rushd argued for a plurality of worlds, only to be silenced by religious doctrine. Even Kepler, who mapped planetary motion, wrote science fiction about lunar civilizations, less a prediction than a thought experiment. The tension between these views wasn't just academic, it was existential. If other worlds existed, did that diminish Earth's significance, or did it expand the canvas of creation? Modern astronomy answers with a resounding yes to both. The Kepler Space Telescope revealed that planets outnumber stars in our galaxy, with billions potentially Earth-like. The TRAPPIST-1 system alone has 7 rocky worlds, 3 in the habitable zone. Yet the sheer abundance doesn't dilute Earth's rarity, it reframes it. We're not special because we're alone, but because we're the first, as far as we know, to ask the question. The myth of uniqueness hasn't vanished, it's evolved. Instead of assuming life is exclusive to Earth, we now hunt for biosignatures in the atmospheres of exoplanets, scanning their light for traces of oxygen or methane. The search itself is a callback to humanity's oldest instincts. Just as sailors once navigated by the stars, the James Webb Space Telescope peers into exoplanet atmospheres, analyzing starlight filtered through their skies. The methods are cutting edge, but the quest is ancient. Are we alone? The answer, whatever it may be, won't just rewrite science textbooks, it'll redefine our place in the cosmos. Whether we find microbial life on a distant world or silence in the void, the very act of looking bridges the gap between myth and reality, between Bruno's vision and our own. Perhaps the most profound shift isn't just in what we've found, but how we see ourselves. Exoplanets haven't erased Earth's importance, they've contextualized it. We're no longer the singular masterpiece of creation, but neither are we an accident. We're participants in a universe so vast, so fertile with possibilities, that the idea of life elsewhere feels less like heresy and more like destiny. The stars, it seems, have been waiting for us to catch up. Humanity's obsession with flight didn't start with the Wright brothers. It began in the stars. Long before blueprints and wind tunnels, we wove our longing for the skies into myth. The story of Icarus, with his waxen wings soaring too close to the sun, wasn't just a cautionary tale. It was a primal blueprint for what we might one day achieve. Halfway across the world, ancient Hindu texts describe the Vimana, fantastical flying chariots said to traverse the heavens. These weren't mere fantasies, they were early flight manuals written in the language of dreams, proof that the urge to defy gravity lies deep in our bones. Fast forward to the 20th century, and those dreams took tangible form. The same year Chuck Yeager broke the sound barrier in 1947, science fiction writers like Arthur C. Clarke were sketching out space stations and lunar colonies. What's striking isn't just how quickly fiction became reality, but how closely the two intertwined. The Apollo program didn't just land humans on the moon, it fulfilled a narrative we'd been writing for millennia. When Neil Armstrong took that first step, he wasn't just a test pilot, he was Icarus rewritten, a hero who flew too high and didn't fall. Now the baton has passed to a new generation of mythmakers. Companies like SpaceX and Blue Origin aren't just building rockets, they're resurrecting ancient ambitions with modern materials. The Starship, with its stainless steel hull and Martian aspirations, echoes the Vimana's promise of celestial travel. Even the names carry mythic weight. Artemis, NAS, a moon program named after Apollo's twin sister, as if the gods themselves are passing the torch. The line between legend and launchpad has never been thinner. What's mesmerizing is how these old stories foreshadowed modern challenges. Icarus' fatal flaw, his wings melting under solar heat, mirrors the thermal dilemmas engineers face when designing re-entry shields. The Vimana's described propulsion, often dismissed as fantasy, now finds loose parallels in theoretical concepts like antimatter drives. These myths weren't just whimsy, they were thought experiments, testing the boundaries of possibility long before laboratories could. Yet the real magic lies in what's still to come. Private companies are democratizing space, turning what was once a superpower rivalry into a playground for innovators. Tourists circle the Earth in capsules, while prototypes for orbital hotels float through city designs. The dream is no longer just to visit space, but to belong there, a vision that would make Daedalus proud. Whether it's Musk's Mars colonies or Bezos' vision of floating space habitats, we're not just reaching for the stars, we're building ladders to meet them halfway. Perhaps that's the true legacy of these ancient stories. They weren't warnings, but invitations daring us to try, to fail, and to try again. Every rocket that streaks through the atmosphere carries more than satellites or supplies. It carries the collective imagination of every culture that ever looked up and wondered, what if? The myths got one thing wrong, though. We weren't meant to fall, we were meant to keep climbing. Astrobiology reveals a fascinating paradox. The more we search for alien life, the more we uncover about ourselves. Consider the Dogon people of Mali, whose oral traditions describe the star Sirius as a binary system centuries before telescopes confirmed its companion, Sirius B. Some see this as evidence of ancient alien contact, while anthropologists suggest it reflects deep observational skills passed through generations. Either way, the story speaks to a universal human impulse, the longing to connect with intelligence beyond our world. Fast forward to today, and that same longing drives billion-dollar projects like SETI, scanning the cosmos for radio whispers from distant civilizations. The tools have changed, but the question remains eerily similar. Are we the universe's sole storytellers, or merely one voice in a cosmic chorus? This duality plays out vividly in our exploration of Mars. Ancient myths often portrayed the red planet as a god of war, a harbinger of chaos. Now, robotic geologists like Perseverance scour its deserts not for deities, but for fossilized microbes, tiny echoes of what may have been a second genesis of life in our solar system. The shift from gods to bacteria might seem like a downgrade, but scientifically, it's revolutionary. Finding even a single alien microbe would prove life isn't a fluke confined to Earth. but a natural phenomenon as woven into the fabric of the cosmos as stars and galaxies. The implications would ripple through theology, philosophy, and science, forcing us to reinterpret everything from Genesis to the Drake equation. What's striking is how these parallel searches, one rooted in myth, the other in spectrometry, keep converging. The Nazca lines, those massive desert drawings visible only from the air, sparked theories of ancient alien runways. Today, astronomers design optical messages in a bottle, like the Arecibo transmission, aimed at hypothetical civilizations. Both endeavors assume a shared language of geometry and mathematics, a hope that intelligence, no matter how alien, might recognize the same patterns. Even the Vatican's observatory, once tasked with defending Earth's centrality, now hosts conferences on astrobiology, pondering whether extraterrestrial life would require its own redemption. Yet for all our technology, the silence is deafening. 70 years of SETI have yielded no definitive signals, while Martian soil remains stubbornly ambiguous. Some argue this absence is itself a message, that advanced civilizations might be vanishingly rare, or that they deliberately hide from dangers we can't yet fathom. Others suggest we're looking for the wrong things, like ancient cultures mistaking volcanic eruptions for divine wrath. Perhaps alien life doesn't use radio waves or leave fossils, but communicates through neutrino bursts or exists as floating plasma in gas giants. The universe, after all, owes us neither answers nor company. This search, whether through telescopes or tablets, ultimately mirrors humanity's journey from isolation to connection. The same people who painted star beings on cave walls now direct lasers toward exoplanets. Whether we find microbes or messages, or nothing at all, the act of seeking expands what it means to be human. After all, isn't the most profound discovery not just who's out there, but who we become in the process of looking? The idea that our universe might be just one of countless others isn't some modern flight of fancy. It's a thread woven through human history, appearing in myths long before it showed up in physics equations. Take Hindu cosmology, where the Rig Veda describes endless cycles of creation and destruction, each giving rise to new universes like bubbles forming in an infinite ocean. Or the Norse 9 realms connected by the great tree Yggdrasil, each world with its own rules and inhabitants, gods, giants, humans existing simultaneously yet apart. These weren't just colorful stories, they were early attempts to grapple with a truth that still eludes us. Reality might be far bigger, stranger, and more fragmented than our senses suggest. Fast forward to today, and the multiverse has traded mythic imagery for mathematical rigor. Some versions spring from quantum mechanics, where every decision spawns branching timelines, a concept Hugh Everett dubbed the many worlds interpretation. Others emerge from cosmic inflation theory, suggesting our universe is just one bubble in a frothing sea of spacetime, each with its own laws of physics. String theory takes it further, proposing a landscape of possible universes numbering 10 to the 500th power. The numbers are so vast they make mythology's infinite realms seem quaint by comparison. Yet the underlying impulse is identical, to push past the limits of what we can observe and imagine what lies beyond. What's striking isn't just the similarity of the ideas, but how differently they're received. Ancient cultures treated parallel worlds as spiritual truths, places you might visit in visions or after death. Modern physics treats them as testable hypotheses, or at least mathematically plausible ones. When scientists talk about the multiverse, they're not invoking gods or cosmic trees, but quantum fluctuations and vacuum energy. The language has changed, but the awe remains. Even the criticisms mirror each other. Just as skeptics dismissed the 9 realms as pagan fantasy, Some physicists argue the multiverse is untestable, more philosophy than science. Yet the multiverse persists because it solves puzzles. Why does our universe seem finely tuned for life? In a multiverse, every possible configuration exists somewhere. We just happen to be in one where the constants allow galaxies, planets, and us. It's the anthropic principle dressed in equations, a cosmic answer to the luck of our existence. And like the myths before it, the multiverse forces us to confront our smallness. If Hindu seers felt humility before the endless cycles of Brahma's breath, how much more staggering is the thought of infinite universes, some with no stars, others with laws we can't even comprehend. Perhaps the most poetic twist is how these theories loop back to storytelling. Physicists don't just calculate multiverses, they visualize them. Brain theory imagines universes as sheets floating in higher dimensions, close enough to almost touch. Bubble universes collide in simulations, leaving hypothetical scars in the cosmic microwave background. These aren't just diagrams, they're modern creation myths, told in the language of 10-dimensional geometry. The Norse had their rainbow bridge Bifrost. We have wormholes and quantum entanglement. Different metaphors, same yearning to map the unmappable. So the next time you hear about the multiverse, don't just think of equations, think of the shamans and poets who first dared to imagine more worlds than one. They may not have had telescopes or particle colliders, but they understood something essential. The universe has always been bigger than our eyes can see. Whether you prefer your parallel realms woven from starlight or string theory, the message is the same: reality is richer, wilder, and more mysterious than we'll ever fully know. And that's a story as old as time. Long before telescopes pierced the heavens, priests and shamans gazed upward, interpreting celestial patterns as messages from the gods. The Babylonians tracked Venus to predict harvests and wars, while Mayan astronomers used the stars to time sacred rituals. These ancient sky watchers were humanity's first data scientists, finding meaning in the chaos of the cosmos with nothing but intuition and patience. Today, we've traded star charts for neural networks, but the quest remains eerily similar: to decode the universe's hidden patterns. Only now, instead of reading omens in meteor showers, we train artificial intelligence to predict galaxy collisions or map dark matter's invisible web. The parallels run deeper than you might think. Take the Gaia spacecraft, which has catalogued over 1 billion stars with pinpoint precision, a dataset so vast no human could process it alone. Enter AI, sifting through this celestial haystack to find needles like hypervelocity stars fleeing the Milky Way or distant quasars flickering at the edge of time. These algorithms don't just crunch numbers, they spot connections even seasoned astronomers might miss, much like how Delphi's priestesses once deciphered prophecies in the rustle of leaves. The tools have changed, but the goal hasn't: to see what others can't. What's revolutionary is how these digital oracles handle ambiguity. Ancient diviners often spoke in riddles. Think of the cryptic warnings from the oracle at Delphi. Modern AI, too, deals in probabilities, calculating the likelihood of a supernova in a nearby galaxy or the chance of an exoplanet having liquid water. The difference: while a Babylonian priest might attribute a comet's appearance to divine wrath, machine learning identifies it as an icy remnant from the solar system's birth, tracing its orbit back 4 billion years. Both approaches seek order, but one relies on myth, the other on mathematics. Yet for all its power, AI in astronomy isn't about replacing human curiosity, it's about amplifying it. When researchers used neural networks to analyze gravitational wave data from colliding black holes, they didn't just confirm Einstein's equations, they uncovered subtle ripples in spacetime that hinted at previously invisible cosmic phenomena. It's as if we've been given a new sense, one that lets us hear the universe's secrets in wavelengths of data. The priest astronomers of old would recognize that thrill, the moment when the unseen suddenly comes into focus. Perhaps the most poetic twist is how these technologies are resurrecting forgotten knowledge. In 2021, an AI trained on Indigenous Australian star lore helped identify undocumented celestial events recorded in oral traditions, like a massive supernova witnessed by Aboriginal elders centuries before telescopes. The algorithm bridged epochs, proving that ancient observations and cutting-edge computation can work in tandem. After all, whether you're a shaman memorizing the sky's stories or a coder writing a deep learning script, you're part of the same timeless pursuit: to look up and wonder, then find the tools to understand. The night sky hasn't changed, but how we listen to it, that transformation is only just beginning. Climate change has always felt like a celestial drama to humanity, a story where Earth's fate seemed written in the stars. The Norse envisioned Ragnarok as a time of endless winter, when the sun would darken and the very fabric of the world would unravel. The Maya tracked climate cycles in their calendars, tying droughts to the movements of Venus. These myths weren't just entertainment, they were frameworks for understanding chaos, ways to explain why the weather turned against us. Today, we no longer blame eclipses or angry gods for shifting climates, but the stakes feel just as apocalyptic. The difference: instead of reading omens in the sky, we're reading data from it. Satellites like NAS, Grace, and Europe's Copernicus program have transformed climate science into a cosmic observatory. They measure melting ice sheets down to the centimeter, track ocean currents warming like a fever, and even catch methane leaks invisible to the naked eye. These orbiting sentinels reveal a planet in flux, not because of mythical serpents or divine wrath, but because of something far more mundane and far more fixable: human activity. The numbers don't lie. Carbon dioxide levels haven't been this high in 3 million years, and the 10 warmest years on record have all occurred since 2010. The data strips away the mysticism, replacing Ragnarok's doom with graphs, projections, and a clear message: this isn't destiny, it's physics. What's striking is how these tools also dismantle the old myth of Earth's invincibility. Ancient cultures saw the planet as a steadfast stage, unchanging beneath the drama of the heavens. Now, satellites show us the truth: Earth is fragile, a delicate balance of systems that can tip violently. Greenland's ice sheet, once thought eternal, hemorrhages 260 billion metric tons of ice annually. Coral reefs bleach under heat stress like forests in a drought. Even the jet stream, that invisible river of air guiding weather patterns, wobbles unpredictably as the Arctic warms faster than the equator. The cosmos isn't attacking us, we're unraveling our own safety net. Yet here's the twist: this cosmic perspective doesn't just deliver doom, it offers agency. Myths like Ragnarok were fatalistic, their catastrophes preordained. Science, by contrast, hands us the script and says, rewrite it. Solar panels and wind turbines aren't just technology, they're acts of defiance against the old narrative. When the Parker Solar Probe studies the sun's fury, or when reforestation projects mimic Earth's ancient carbon cycles, we're not pleading with the gods, we're reprogramming the system. Even the language shifts: adaptation replaces prophecy, mitigation over omen. Perhaps the most profound shift is in how we see time. Mythic apocalypses were sudden, spectacular: a wolf swallowing the sun, a flood washing everything away. Climate change is slower, subtler, its disasters creeping in like tides, but that's also its vulnerability. Unlike Ragnarok's unstoppable winter, our warming planet has brakes if we choose to press them. The satellites will keep watching, not as harbingers of doom, but as witnesses to what we do next. After all, the stars have always been silent partners in our stories. It's up to us whether this chapter ends in tragedy or transformation. The night sky has always been a tapestry of power and mystery, but look closely, many of its most luminous figures were women. Artemis, the Greek goddess of the moon, raced her silver chariot across the heavens. Nut, the Egyptian sky mother, arched her star-studded body over the earth each night, swallowing the sun at dusk and birthing it anew at dawn. These celestial women weren't just decorative, they were cosmic forces governing tides, seasons, and the very cycle of life and death. Yet somewhere between myth and telescope, their stories were eclipsed. For centuries, the women who studied the stars were written out of the narrative, their contributions buried like faint constellations hidden by light pollution. The shift from goddesses to exclusion didn't happen overnight. In ancient Babylon, priestesses like Enheduanna mapped Venus's movements, weaving astronomy into temple rituals. Hypatia of Alexandria, a brilliant mathematician and astronomer, met a brutal end in the 4th century, her murder a dark omen of the erasure to come. By the time Galileo trained his telescope on Jupiter, women's access to formal education had been systematically severed. The scientific revolution, for all its strides, unfolded behind a glass ceiling. When Caroline Herschel discovered comets in the 1700s, her brother William received the credit. Maria Mitchell's detection of a new comet in 1847 made her the first American woman to earn international acclaim. But even then, she was barred from faculty meetings at Vassar, forced to listen from the hallway. The irony is crushing. The same cultures that revered sky goddesses denied earthly women the right to study them. Mythology's Artemis could guide hunters, but real women weren't trusted to peer through a lens. Nut's body might cradle the cosmos, but a woman's place was decidedly earthbound. This wasn't just bias, it was a deliberate rewriting of the sky's story, as if the universe itself had been deemed too vast for feminine curiosity. Yet the stars have a way of refusing silence. In the early 20th century, Henrietta Swan Leavitt unlocked the key to measuring cosmic distances by studying pulsating stars, work that Edwin Hubble would later rely on to prove the universe's expansion. Her discovery was revolutionary, but her name was footnote. Cecilia Payne Gaposchkin's doctoral thesis revealed stars were made mostly of hydrogen, overturning decades of assumptions. Her male advisor dismissed it as impossible until a rival scientist reached the same conclusion years later and took the credit. Today, that legacy is being recalibrated. Astronomers like Jocelyn Bell Burnell, who discovered pulsars only to see her male advisor awarded the Nobel, now mentor young women in radio astronomy. Mae Jemison, the first black woman in space, carries the torch for a more inclusive cosmos. NASA's Artemis program, named for that moon goddess, aims to land the first woman on the lunar surface, a poetic correction to centuries of exclusion. Even the night sky's geography is being redrawn. The IAU's recent star-naming initiatives honor figures like Wang Zhenyi, an 18th-century Chinese astronomer who defied Confucian norms to study the heavens. The lesson here isn't just about equity, it's about how much richer the cosmos becomes when everyone gets to look up. The same stars that inspired Artemis and Nut now guide astrophysicists probing dark matter or engineers designing Mars rovers. The universe, it turns out, was never a male domain. We just closed the door on half its interpreters. As those doors creak open, something extraordinary happens. The sky regains its old magic, not as a relic of myth, but as a frontier where every voice belongs. The goddesses would be proud. Polynesian navigators didn't just sail, they danced with the stars. Without compasses or charts, they crossed thousands of miles of open ocean. guided by the rise and set of constellations, the swell of waves, even the flight patterns of birds. Their star compass, known as the Cape Huwetu, wasn't a physical tool but a mental map memorized through generations of oral tradition. They could pinpoint islands invisible over the horizon by reading the ocean's reflections of clouds or sensing subtle shifts in currents, a skill modern science now calls wayfinding. This wasn't luck or mysticism, it was an intricate science of observation refined over centuries. When European explorers first encountered Polynesians in the 18th century, they dismissed these techniques as primitive guesswork. Yet today, NASA engineers study wayfinding principles to design backup navigation systems for spacecraft, proving the so-called myths were always rigorous astronomy in disguise. Half a world away, the Maya were conducting celestial calculations that would make a modern physicist pause. Their Dresden Codex, a bark paper book surviving centuries of colonization, contains Venus tables so precise they could predict the planet's appearances within a single day over a 500-year span. They tracked lunar eclipses with cycles lasting 11,960 days, a figure off by just 33 minutes from today's measurements. Even their pyramids doubled as observatories, with alignments marking solstices and the zenith passage of the sun, when shadows vanish at noon. Spanish priests burned thousands of these texts as heathen superstition, not realizing they were erasing archives of astronomical genius. The pattern repeats globally. Aboriginal Australians map the sky not just with stars but with dark constellations, shapes traced in the Milky Way's dust lanes, like the emu in the sky whose position signaled egg-laying season. The Navajo used celestial patterns to time crop plantings, while the Inca's sex system aligned temples with celestial events, turning Cusco into a stone calendar. These systems weren't crude predecessors to science, they were science tailored to the needs of their cultures. The difference lay in delivery. Where Western astronomy codified knowledge in textbooks, indigenous traditions wove it into story, song, and ritual, modes colonizers failed to recognize as data. Today, the tide is turning. Astronomers collaborate with Maori elders to rediscover lost star lore, while universities integrate indigenous fire management practices based on celestial cycles into climate models. The TMT telescope protests on Mauna Kea weren't just about land. They were a demand to respect other ways of knowing the cosmos. When native Hawaiian activists chant about the summit being sacred, they are also defending a lineage of celestial observation as rigorous as any observatory's findings. The lesson here isn't just about correcting historical slights. It's about humility. Western science once assumed it had a monopoly on truth, yet Polynesian navigators could sense land from wave patterns long before sonar existed. The Maya's Venus tables rivaled anything from medieval Europe. Perhaps the real divide wasn't between myth and science, but between whose knowledge got taken seriously. As we face challenges like climate change and space exploration, blending these perspectives isn't just fair, it's essential. The stars, after all, never belonged to one culture. They've always been a shared inheritance, whispering different truths to those willing to listen. The Vatican might seem like an unlikely place to find a telescope, but atop the papal summer residence in Castel Gandolfo, astronomers have been studying the stars since the late 16th century. This isn't just a historical curiosity, it's a living testament to how faith and science can coexist. The Vatican Advanced Technology Telescope, perched on Mount Graham in Arizona, peers into deep space with a mirror polished to atomic precision, searching for exoplanets and galactic structures. Far from rejecting cosmic discoveries, the Catholic Church has quietly integrated them, framing the Big Bang as compatible with divine creation and even hosting conferences on astrobiology. When Pope Francis blessed the astronauts aboard the International Space Station, he didn't warn them against scientific hubris. He celebrated their work as a continuation of humanity's God-given curiosity. This harmony isn't unique to Christianity. Japan's Hayabusa 2 mission, which returned asteroid samples to Earth in 2020, carried Buddhist sutras etched onto tiny titanium plates, prayers sent into the cosmos like interstellar message bottles. Tibetan monks debate the nature of reality using frameworks startlingly similar to quantum physics, while Hindu temples align with solstices, their architecture encoding celestial mathematics. These traditions don't see telescopes as threats. They're tools to deepen wonder, bridging the material and the mystical. Yet history reminds us the path hasn't always been smooth. Galileo's trial in 1633 looms large, a cautionary tale of dogma clashing with discovery. But even that story is more nuanced than the myth suggests. The Church didn't reject heliocentrism outright. It demanded proof, a standard any scientific claim would face today. Galileo's real misstep was arrogance, insisting he'd definitively proven Earth's motion when his evidenced tidal theories based on flawed mechanics was shaky. By contrast, Jesuit astronomers like Christoph Scheiner quietly accepted sunspots, adapting their theology to accommodate new data. The conflict wasn't between faith and science, but between institutional caution and individual brilliance. Modern tensions often mirror this dance. When the discovery of exoplanets raised questions about multiple worlds harboring life, theologians didn't panic, they speculated. Could Christ's redemption extend to aliens? Might other civilizations have their own covenants with the divine? These aren't fringe ideas, they're serious dialogues in institutions like the Vatican Observatory and the Center for Theology and the Natural Sciences. Even the Dalai Lama engages with neuroscientists, exploring how Buddhist concepts of consciousness align with cutting-edge research. The real revelation here isn't just that religions adapt to science, it's that many were doing science all along. Medieval Islamic astronomers refined the astrolabe, their prayer times dictated by celestial mechanics. Jain cosmology proposed a cyclical universe eons before modern multiverse theories. What we call myth was often proto-science, a first draft of cosmic understanding. The difference now is the tools. Where ancients watched the sky with naked eyes and prayer, we deploy spectrometers and satellites. But the impulse remains the same, to seek, to question, to marvel. Perhaps that's the ultimate lesson. The night sky doesn't belong to any one tradition. It's a shared frontier where psalmists and physicists alike stand humbled. When a supernova blazes across the cosmos, it doesn't ask if you're holding a Bible or a textbook. It simply lights the way for all who look up. And in that light, the old dichotomies fade, leaving only the endless collective gasp of wonder. Long before telescopes or textbooks, humans painted their cosmic questions onto cave walls. In the Lascaux caves of France, 17,000 years ago, someone daubed a bull's shoulder with clusters of dots, a possible depiction of the Pleiades, that shimmering star cluster revered by cultures worldwide. Fast forward to the ceiling of New York's Grand Central Terminal, where a golden mural of constellations glows, their positions precisely reversed, not a mistake, but a deliberate choice to show the sky as God would see it from above. Art has always been humanity's first language for the cosmos, translating wonder into pigment, stone, and light. Consider the celestial precision of Vincent van Gogh's Starry Night. Swirling galaxies of paint mirror the turbulence of actual nebulae, a phenomenon astronomers wouldn't photograph for another century. Van Gogh, writing to his brother Theo, described the night sky as a living thing. "I don't know anything with certainty, but seeing the stars makes me dream." Decades later, Hubble's images of whirlpool galaxies would echo his brushstrokes, proving intuition sometimes outpaces instrumentation. Similarly, Hokusai's The Great Wave isn't just a seascape, its foam curls mimic the fractal patterns of cosmic radiation, a hidden geometry linking ocean and universe. Film 2 has wrestled with the cosmos' grandeur. Stanley Kubrick's 2001, A Space Odyssey didn't just depict space travel, it weaponized silence and scale to evoke the sublime terror of the infinite. The famous jump cut from a bone tossed in the air to a spaceship wasn't just editing, it compressed 4 million years of human evolution into a blink, asking if technology had truly brought us closer to understanding our place in the void. Contrast this with Arrival's linguistic aliens, whose circular script mirrored orbital paths, suggesting that decoding the universe might require abandoning linear thought altogether. Music bends toward the cosmic just as fiercely. Gustav Holst's The Planets assigned Mars the sound of war drums and Venus harp glissandos, long before probes revealed one as a rusty desert and the other a sulfuric hellscape. Sun Ra claimed he was from Saturn, weaving Afrofuturist jazz into a mythology where space wasn't just explored but reclaimed. And who could forget David Bowie's Space Oddity, turning astronaut Major Tom into a secular Icarus, floating untethered from earthly concerns. These artists didn't just describe the cosmos, they sonified its loneliness and majesty. Even architecture bows to celestial patterns. The pyramids of Giza align with Orion's belt, their corridors pointing to pole stars ancient Egyptians used to navigate the afterlife. Borobudur, the massive Buddhist temple in Indonesia, is a stone mandala of the universe, its tiers representing layers of cosmic consciousness. Modern planetariums, with their domed screens, resurrect the ancient impulse to sit beneath a simulated sky and marvel. The line between sacred space and scientific theater blurs both are acts of reverence. What unites these works across millennia isn't just subject matter, but a shared mission to render the incomprehensible tangible. Science quantifies the universe's laws, art quantifies its emotional weight. When Navajo sand painters recreate constellations or Olafur Eliasson installs artificial suns in museum halls, they're not contradicting astrophysics, they're expanding its vocabulary. The cosmos doesn't care if we paint it in ochre or pixels, but in trying, we edge closer to answering the oldest question art and science share. What does it mean to be small, brief, and brilliant under such an endless sky? UFO stories have a way of blurring the line between ancient awe and modern speculation, like mythology remixed for the digital age. Centuries ago, people saw chariots of fire or celestial messengers. Today, those same visions wear chrome plating and blinking lights. The shift from sky gods to extraterrestrial visitors isn't just a change of costume. It's a window into how humanity processes the unexplained. Take the infamous 1947 Roswell incident. A crashed weather balloon became an alien spacecraft in the public imagination almost overnight, not because the evidence demanded it, but because the world was primed for new myths. The atomic age had dawned, the space race loomed, and suddenly the idea of visitors from the stars felt less like fantasy and more like inevitability. What's fascinating is how these stories echo older traditions. The Navajo spoke of the star people, benevolent beings who brought knowledge from the heavens. Medieval paintings depict strange aerial phenomena like the 1566 Nuremberg sky battle, where townsfolk reported cylinders and spheres clashing overhead. Fast forward to 2021, when the Pentagon released its UAP report, and you'll notice the same pattern. Witnesses describing objects that defy known physics, performing maneuvers no human aircraft could match. The difference: today's sightings come with radar data and fighter jet footage. forcing even skeptics to admit some cases resist easy explanation. But here's where the myth-making collides with methodology. While 95% of UFO, or UAP, as the military now calls them, reports turn out to be drones, weather anomalies, or classified aircraft, that remaining 5% gnaws at the edges of our understanding. Take the 2004 Nimitz encounter. Navy pilots tracked a tic-tac-shaped object accelerating instantaneously with no visible propulsion. Scientists proposed theories, from atmospheric plasma to sensor glitches, but none fully account for the corroborated eyewitness and instrument data. It's a reminder that the universe is still capable of surprises, whether they're secret tech or genuinely unexplored phenomena. The real tension lies in how we respond. Pop culture treats UFOs as either conspiracy fodder or sci-fi plot devices, while serious researchers struggle to be heard over the noise. Astronomers like Harvard's Avi Loeb argue for a data-driven approach, launching projects like Galileo to scan the skies for potential artifacts. Meanwhile, the US government has shifted from dismissal to cautious transparency, declassifying videos and forming task forces. This isn't about proving aliens exist, it's about acknowledging that some mysteries warrant tools sharper than rumor. Perhaps the most telling detail is how these stories adapt. Ancient sky gods reflected their culture's thunderbolts for Zeus, sun disks for Ra. Modern UFOs wear the aesthetic of their time, sleek saucers in the 50s, black triangles in the 80s, and now drone-shaped objects in the age of AI. The through line isn't evidence of visitation, but humanity's endless hunger to wonder what if. Whether these sightings reveal extraterrestrial neighbors or simply the limits of our knowledge, they prove one thing: the night sky still holds stories we're not yet equipped to tell. Light pollution doesn't just dim the stars, it silences the stories they carry. Imagine standing where a Babylonian priest once traced the path of Jupiter, only to see a washed-out sky, its constellations drowned in the orange haze of streetlights. That's the reality for 80% of the world's population, living under skies so bright they'll never glimpse the Milky Way. The glow of cities doesn't just obscure celestial objects, it severs a connection stretching back to the first humans who looked up and saw gods, animals, and epic tales written in starlight. The Pleiades, Orion, the North Star, these weren't just navigation tools or seasonal markers. They were the original library of human imagination, a shared heritage now fading behind a veil of artificial light. The consequences ripple far beyond nostalgia. Migratory birds, tuned to celestial cues for millennia, spiral confused around skyscrapers, their internal compasses scrambled by urban glare. Sea turtles' hatchlings evolved to crawl toward the moonlit ocean, now stumble inland toward parking lots. Even humans suffer. Our circadian rhythms, synchronized by natural darkness, falter under perpetual twilight, with studies linking light pollution to sleep disorders and increased cancer risks. The night sky isn't just a backdrop, it's a biological imperative woven into the DNA of countless species. Yet a quiet rebellion is growing. Dark sky preserves, like Utah's Natural Bridges National Monument or Chile's Atacama Desert, are reclaiming the stars with strict lighting regulations. These sanctuaries don't just protect telescopes, they safeguard the intangible. When you stand beneath a truly dark sky, something primal awakens. The Magellanic Clouds, invisible in most cities, sprawl across the southern sky like ghostly rivers. The zodiacal light, sunlight reflecting off interplanetary dust, paints a faint pyramid on the horizon. These phenomena once guided Polynesian navigators and inspired Mayan astronomers. Now they're reduced to footnotes in light-polluted lives. The battle isn't just technical, it's cultural. Indigenous communities, from the Maori to the Navajo, are partnering with astronomers to protect sacred sightlines to solstice-aligned structures or star paths used in ceremonies. In New Zealand, the Aoraki Mackenzie Dark Sky Reserve integrates traditional Maori star lore with modern conservation, teaching visitors that losing the night sky means losing a language older than writing. Meanwhile, artists like photographer Harun Mamadinovic's Skyglow project juxtapose ancient monuments with light-polluted horizons, showing how modern glow erases the same skies those structures were built to honor. Technology offers surprising solutions. Adaptive LED streetlights, which dim when no motion is detected, cut energy waste while preserving darkness. Apps like Loss of the Night crowdsource skyglow data, turning smartphones into citizen science tools. Even space-based initiatives matter. Satellites like the European Space Agency's NightSat monitor global light pollution, revealing that the problem isn't just urban. Industrial fishing fleets now blanket oceans with so much light they're visible from space, disrupting marine ecosystems. The stakes feel existential. Without the stars, we risk forgetting how to wonder. Ancient myths warned of hubris Icarus flying too close to the sun. The Tower of Babel toppled for reaching heaven. Light pollution is their modern counterpart, a tower of watts and lumens that doesn't bring us closer to the cosmos but blinds us to it. Yet every darkened streetlight, every shielded bulb, is a stitch in the unraveling fabric of the night. The fight isn't just for astronomers or romantics, it's for anyone who's ever felt small under the stars and found comfort in that vastness. After all, the universe hasn't gone anywhere. We're the ones who turned away. The question is whether we'll turn back before the last myths flicker out. For millennia, the night sky was humanity's shared inheritance, a boundless canvas where every culture painted its stories without ever worrying about borders or deeds. The Greeks didn't charge royalties for tracing Orion's belt. The Maori didn't fence off the Magellanic Clouds. But today, as corporations file claims to mine asteroids and nations plant flags on lunar soil, the heavens are being parceled up like frontier land. What happens when the myths of a communal cosmos collide with the realities of capitalism and conquest? The answer could redefine not just who owns the stars, but what it means to explore them. Take the case of asteroid mining. Companies like Planetary Resources and Deep Space Industries have spent years developing technology to extract platinum, water, and rare metals from space rocks, resources theoretically worth trillions. In 2015, the US Congress passed the Space Act, granting American companies ownership of whatever they dig up, a move echoed by Luxembourg's similar laws. On one hand, this incentivizes innovation, turning sci-fi dreams into tangible missions. On the other, it risks repeating Earth's ugliest history, the rush to exploit new territories without asking who they truly belong to. Indigenous communities like the Navajo already call this cosmic colonialism, pointing out that asteroids and moons feature in their creation stories as sacred entities, not untapped warehouses. The legal framework is a patchwork of contradictions. The 1967 Outer Space Treaty, signed during the Cold War, declares celestial bodies the province of all mankind, banning national claims, but says nothing about private corporations. It's a loophole big enough to fly a mining drone through. Meanwhile, NASA Artemis Accords, signed by over 30 countries, propose safety zones around lunar operations, raising fears of de facto territorial control. Critics argue this is like claiming ocean ownership because you dropped an anchor. Yet the debate isn't just legal, it's philosophical. Ancient sky myths treated celestial bodies as ancestors, teachers, or divine gifts. Polynesian navigators saw stars as guides, not assets. Even the scientific communities, planetary protection protocols which prevent contaminating Mars or Europa with Earth microbes, reflect a kind of cosmic reverence, acknowledging these worlds as more than real estate. Does turning asteroids into commodities honor that legacy or betray it? There's a middle path. Some propose treating space resources like Antarctica or the deep sea, governed by international treaties that balance exploration with preservation. The Moon Agreement of 1979 suggested this, but only 18 nations ratified it, none of them spacefaring powers. Others advocate for a cosmic commons model, where mining profits fund global education or climate solutions. Imagine a future where asteroid metals build hospitals instead of yachts, or where lunar water fuels interplanetary missions for all nations, not just the wealthiest. The stakes are higher than profit margins. If we let the rush for space resources mirror Earth's history of exploitation, we risk taking our worst habits to the stars. But if we weave mythic ideals of shared wonder into our cosmic laws, space could become the first frontier humanity explores without conquering. The stars have always been storytellers. Now it's our turn to decide, will the next chapter be one of division or of collective awe? The universe is unimaginably vast, with billions of galaxies, each brimming with billions of stars and countless planets nestled in their habitable zones. Given these mind-bending numbers, the idea that Earth is the only place where life has taken root seems statistically absurd. And yet, when we point our telescopes and radio dishes at the cosmos, all we hear is silence. No alien broadcasts, no interstellar travelers, not even a single unmistakable sign that we're not alone. This eerie contradiction is the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" Ancient cultures didn't have this problem. For them, the sky was already crowded not with hypothetical aliens, but with gods, spirits, and celestial beings. The Greeks imagined Olympus hovering just beyond the clouds, while Hindu cosmology described flying cities called vimanas piloted by divine beings. The Dogon people of Mali believed their ancestors came from Sirius, the brightest star in our sky. These weren't just flights of fancy, they were answers to the same fundamental question Fermi posed. If the universe is so big, why does it feel so empty? Modern science offers grim possibilities. Maybe intelligent life is vanishingly rare, snuffed out by asteroid impacts, gamma-ray bursts, or its own self-destructive tendencies. Perhaps civilizations inevitably hit a technological wall, like climate collapse or nuclear war, before they can colonize the stars. Or worse, what if we're the first? Someone had to be, after all. The universe is 13.8 billion years old, but complex life might still be in its infancy. If that's true, then the myths weren't wrong, they were just premature. The skies will be populated one day, just not yet. But there's another, stranger possibility. What if we're not recognizing the signs? Our search for extraterrestrial intelligence assumes aliens think like us, that they'd send radio waves, build megastructures, or leave artifacts we can spot. But what if their technology or their very existence is so alien that we're literally incapable of perceiving it? Imagine an ant staring at a smartphone. It wouldn't see a communication device, it would see a warm, smooth rock. Could we be missing the cosmic equivalent, dismissing alien superstructures as natural phenomena, or misinterpreting their signals as background noise? The most haunting idea of all, maybe we have been contacted, just not in ways our science can yet explain. UFO sightings, crop circles, even ancient astronaut theories all tap into a deep-seated human longing, the desire to believe we're not alone in the dark. Science demands evidence, but myth fills the gaps with stories. Both, in their own ways, are trying to solve the same puzzle. So the next time you look up at the stars, remember, the silence isn't just absence. It's a question, one we're still learning how to ask, and whether the answer comes from a radio telescope or an old legend retold around a fire, the night sky will always be the mirror where we search for our own reflection, hoping, against the odds, to find another face staring back. Imagine the first child born on Mars, gazing up at a sky where Earth is just a bright blue star. What stories will they hear at bedtime? Tales of the brave astronauts who crossed the void, or legends about the red planet itself, its rust-colored deserts personified as a sleeping giant waiting to awaken. Future Martian colonists won't just carry Earth's myths with them, they'll forge new ones shaped by the stark beauty of alien sunrises and the ever-present hum of life support systems. These stories won't replace science, they'll grow alongside it, turning airlocks and hydroponic farms into the stuff of epic poetry. Consider how quickly mythology adapts to new landscapes. When Polynesians settled distant islands, they didn't just transplant old gods, they wove new ones from storm currents and unfamiliar constellations. Mars will be no different. The planet's violent dust storms might become the breath of a capricious wind spirit, while the distant thump of a rover's drill could echo in folktales as the heartbeat of the planet. Even the mundane could transform into legend. A malfunctioning oxygen recycler, barely repaired in time, might evolve into a cautionary fable about respecting the machines that keep humanity alive. The rhythms of Martian life will rewrite timekeeping itself. With a day just 40 minutes longer than Earth's, will colonists stick to Greenwich Mean Time or invent their own calendar, marking years by the planet's slow dance around the sun? Seasonal shifts, subtle compared to Earth's, might still inspire festivals celebrating the thawing of subsurface ice or the arrival of supply ships from Earth. And what of the stars? Without Earth's atmosphere to blur their light, Martian skies will blaze with constellations unknown to terrestrial astronomers, inviting new patterns, new heroes, new celestial maps drawn by minds raised under a dimmer sun. Then there's the ultimate question: how will these future cultures remember us? The pioneers of the 21st century, Elon Musk, NASA engineers, the first boots on Martian soil, could become demigods in retellings, their flaws sanded away by time. Or perhaps they'll be tragic figures, warnings about the perils of clinging to earthly ways. A colony that thrives might spin its founders into a triumphant saga. One that struggles could recast them as reckless gamblers. History, after all, is just mythology waiting to be polished by generations. The most fascinating twist: these stories won't stay confined to Mars. As settlements spread to Europa's ice caves or Titan's methane lakes, each world will develop its own lore, its own creation myth starring robots and genetic pioneers. Yet beneath the high-tech veneer, the human impulse will remain the same: to make sense of the unknown by giving it a name, a face, a story. The universe may be indifferent to our tales, but we've never let that stop us before. And when those first Martian children whisper legends under a sky streaked with asteroid trails, they'll prove that wonder isn't bound by gravity. It's coded into our DNA, ready to bloom wherever we plant our feet. The night sky has never been just one thing. It's a living archive where the oldest human stories shake hands with the newest scientific discoveries. Think about the last time you stepped outside on a clear evening. Did you trace the Big Dipper's handle like an ancient navigator, or did you marvel at how those stars are actually light years apart, their patterns an illusion of perspective? The truth is, you were doing both. Every constellation is a palimpsest, layered with millennia of interpretations. The same stars that guided Polynesian voyagers across the Pacific now help astronomers measure the expansion of the universe. This duality isn't a contradiction, it's a collaboration. When the James Webb Space Telescope captures the birth of a star, it doesn't erase the Navajo story of the hero twins who placed those stars in the sky. It adds another verse to the poem. Science tells us how supernovae forge the elements in our bones, while myths remind us that those explosions were once seen as dragons or dying gods. One framework calculates, the other contemplates, and somewhere in the space between we find meaning, yet there's a danger in leaning too far either way. Dismiss myth as mere superstition, and you risk reducing the cosmos to a sterile spreadsheet of data. Ignore science, and you surrender the tools to test whether Sirius really is a binary star or just the eye of a celestial wolf. The magic happens in the balance, like modern astronauts who recite poetry while calculating orbital trajectories, or indigenous elders who weave traditional star knowledge into planetarium shows. The sky is big enough for all these ways of seeing, so what's next? As we peer deeper into black holes and dream of Martian cities, let's carry forward both the curiosity that built telescopes and the awe that painted goddesses across the heavens. When the Artemis generation lands on the moon, they won't just be collecting rock samples, they'll be walking in the footsteps of Selene and Chang, adding new chapters to a story that's still being written. The universe doesn't care if we describe its laws in equations or epic verse, but we're richer when we use both. Tonight, step outside, let your eyes adjust. The stars overhead are the same ones that inspired Kepler's math and Van Gogh's brush, that guided Harriet Tubman north and sailors home. Whether you see cosmic chemistry or celestial stories, or better yet, the dance between them, you're part of a tradition as old as humanity itself. The conversation between myth and science never ends, it just evolves. So keep looking up, keep wondering, and most of all, keep sharing what you find. After all, the best discoveries are the ones we